Today we are going to see all the formulas related to the chapter Some Basic Concepts of Chemistry. First of all, we are going to see relation between moles. When moles is converted into any other factor, we are going to multiply. When moles is converted into mass, we multiply it with molar mass, while the opposite is when we divide it. Similarly, when moles is converted to number of particles, we multiply it, with Na, that is the Avogadro number. But when number of particles is converted to mole, we divide with Na. Now when moles is converted to volume of gas, we need to multiply it with 22.4 liter. When opposite is occurring, then we divide it by 22.4 liter. Next is relation between molar mass and vapor density. Always molar mass is said to be 2 times vapor density. This is useful many times in the question of empirical relation. After that comes mass percentage. Mass percentage is mass of that component, divided by total mass of the compound. If suppose they have given Na2SO4 and they have asked the mass percentage of sodium, then over here there are 2 sodium, so 2 multiplied by mass of 1 molar mass of 1 sodium divided by molar mass of Na2SO4. So this would be the basically mass percentage of sodium. After that comes molecular formula. Molecular formula, which is there, a relation with empirical formula, is nothing but N multiplied by empirical formula. Now the question arises, what is N? So N, which is there, it is nothing but molar mass upon empirical mass. Once we find the value of N, we can easily find the value of molecular formula. 1 Newton, which is there, it is said to be 10 to the power 5 dyne. 1 electron volt, which is there, it is said to be 1.6 into 10 to the power minus 19 joules. 1 inch is 2.54 centimeter. After that, conversion of joule into erg, that is 1 joule is 10 to the power 7 erg, 1 angstrom is 10 to the power minus 10 meters. These are all basic things which are need to be known throughout other chapters as well. Then conversion for pressure, that is 1 atm is nothing but 760 torr or mm of Hg, which is also converted into 1.014 bar, or it is also 1.013 into 10 to the power 5 Pascal. These conversions are much more important rather than any other. Next is molarity. Molarity is number of moles divided by volume of solution taken in liter. So number of moles divided by volume of solution in liter. What is molarity? Molarity is number of moles divided by weight of solvent in kg. After that, normality. Normality, which is there, it stands for basically gram equivalent of solute divided by volume of solution in liter. Then parts per million by mass. This is nothing but mass of the component, component divided by total mass multiplied by 10 to the power of 6 per million. Next, relation between normality and molarity is nothing but normality, which is there, it is molarity multiplied by n factor. N factor, which is there, basically for acids or bases, is number of replaceable H plus or number of replaceable OH minus. Similarly for ions, there is total positive charge or the total negative charge present on them. These are all the n factors used. Next is for dilution. For dilution, which is there, the formula basically is used M1 V1 will be equivalent to M2 V2. Here instead of molarity N1 V1 equivalent to N2 V2 is also used. For mixing non-reacting solution, that is if we are mixing H2SO4 with H2SO4, they are not going to react, rather it's just going to mix up with having different volumes. Then the formula would be M1 V1 plus M2 V2, which will be equivalent to M3 V1 plus V2. Next is acid base mixing. Here the formula is higher equivalent minus lower equivalent will be equivalent to final normality multiplied by final volume. The term equivalence would be explained just over here. See, before that, relation between molality, density and molarity. Okay, molality, density, molarity. So M will be equivalent to molality equals 1000 multiplied by molarity divided by 1000 multiplied by density minus M into molar mass of solute. Okay, after that comes equivalence, okay, which we were discussing over here, equivalence, or it can also be called as number of equivalence or gram equivalence. Gram equivalence we saw in the formula over here, gram equivalence of solute in the formula of normality, this term which was used. This also means equivalence. Okay, so it is nothing but it is normality multiplied by volume in liter. First this formula. Second formula could be the mass which is given. So we write mass given divided by equivalent mass. Equivalent mass is a new topic which we'll see over here what it stands for. And the third formula is moles multiplied by N factor. N factor we saw for acid, if we have been given H2SO4, we can see there are 2 H, so here N factor would be 2. Similarly for base respectively, if they have given KOH 1, so then it's 1. For salt K2SO4, here we see either that's 2 plus or 2 minus, but we take either positive or negative, so we take 2. Okay, so these are the values of N factor for acid. In redox reaction also it would come, but we can see it later on. For equivalent mass, the formula stands as molar mass divided by N factor. After that is these two, that is KMnO4 and K2Cr2O7. In acidic medium, they are value of N factor respectively. These are N factor values for each of them. For a KMnO4 it is 5, then neutral is 3, base is 1. Because it can be seen in all the three mediums, but for K2Cr2O7 only acidic medium it acts as the agent, so it has only 6 as the N factor over here. So apart from this, this was all for some basic concepts of chemistry.